In this video, we're going to learn about percent yield. Now, in stoichiometry thus far, we've assumed a 100% yield, which just means that um, any reaction goes exactly 100% towards where you're expecting. In reality, you might not end up with exactly the amount of a product of a reaction that you had hoped for. And so let's consider this problem right here. So if we have 3.03 grams of hydrogen and we react it with excess oxygen, um, we can figure out what we theoretically should get in terms of the amount of water. But let's say that we measure at the end and we find there are 24.9 grams of water. Let's compare that amount that we actually got, our actual yield, to the theoretical yield that we could have got and figure out a percent. So I've started my mapping here. I know that I've got the 24.9 grams of actual yield, but what I want to do is say, calculate the theoretical yield so that I can compare the actual and theoretical and get a percent out of it. So what I'll do next is I will put in all my conversion factors. I know first I need to go from my 3.03 grams of hydrogen to moles. From moles, I can get to moles of water, and then from moles of water, I can get to this theoretical yield of water. I've got my conversion factors here, my molar mass of H2, my molar mass of H2O, and I know that I've got a 2 moles of water for every 2 moles of hydrogen as my mole ratio that I took from the coefficients of the equation. Now, since I have 3 steps here, I need 3 conversion factors and start with my 3.03 grams of hydrogen going to my unknown grams of water. I start by saying I've got 1 mole of H2 over 2.02 grams of H2. Next, I can put in my 2 moles of H2O for every 2 moles of H2. And my last conversion factor is that I multiply by 18.02 grams of H2O per every mole of H2O. I get all of my units canceling except the grams of H2O, which gives me my final answer of apparently 27.03 grams. Now, I next can kind of take out the rest and look at just here, my actual and theoretical. And if I take the actual and divide it by the theoretical and multiply by 100%, well, then from that equation, I get 92.1%. That's my percent yield that I got just from this last step. All right. Percent yield, there are actually 3 ways that we can look at it. And we had one where you sort of start with a known amount of stuff. You think, hey, maybe I'll get a certain amount of it. And you measure in the end and only get something less than that. A different way of looking at percent yield is this. Let's say that we do a reaction over and over and over again. We always get about 92%. If I react 3.03 grams of hydrogen, let's say this is just what I have, the hydrogen that I have, I know that I can get a theoretical yield, but if I know that I only ever get 92% of that, I know that my actual yield is probably going to be, well, 92% of the theoretical. So we could solve this problem trying to find the actual yield. But to get there, I need, of course, the theoretical yield. And we'll get the theoretical yield in exactly the same way that we did in the previous case. I just say that we start with 3.03 grams of hydrogen, use molar mass to get to moles of hydrogen, use the mole ratio to get to moles of water, and then use the molar mass to get to the theoretical yield of water, which is exactly what I'm doing here. This is the same as I did before, so I'll go quickly. I know that my theoretical yield is about 27.0 grams, and I can put that in as my theoretical yield. So how to do the rest of this? Well, I'm going to get rid of all the other stuff and just look here, because basically we've got this pretty simple equation. We've got an unknown grams of actual yield divided by a 27.0 gram of theoretical yield times 100% equals 92.0%. Well, I can bring over our theoretical yield and divide out the 100% on both sides, and that will give me a apparently 24.8 grams are my actual yield. So if everything had gone perfectly, my 3.03 grams of hydrogen would have afforded us about 27 grams of water. However, instead of getting 27 grams of water, I got about 92% of that, which is 24.8 grams of water. All right, problem type 3. Let's say that I need 36.04 grams of water. That's what I need to get. And every time I try to form water, I only get 92% yield. How much hydrogen do I actually really need to use in order to get my 36.04 grams of water, accounting for the fact that I'm still going to lose 8%? Well, here's my setup, right? This is what I know. I need to find this value. I know this, and I know this. Initially, I'm just going to use this simple equation. Actual over theoretical times 100% gives us 92%. And that's just manipulating the equation that you saw in the previous case, except this time our variable is the denominator. And if we were to do that, we'd find that 36.04 grams divided by 0.92 is going to give us 39.2 grams as our theoretical yield. Moving backwards from here, we go from grams of theoretical yield to moles of theoretical. We can get moles of hydrogen and then to grams of hydrogen, which is sort of standard bread and butter stoichiometry. I'm not even going to show the conversion factors because it's the same as before, but basically if we have 39.2 grams as our theoretical, we can convert to moles of water by dividing by the molar mass, do the mole ratio, and then multiply by our 2.02 grams of hydrogen per mole, and that gives us 4.39 grams of hydrogen, which is more hydrogen than you'd find in 36.04 grams of water, but it's more because, again, we're not shooting for 36 grams of water, we're shooting for 39 grams of water, and accounting for the fact that we lose about 8%. So if we wanted to get 36.04 grams of water, we'd actually have to add a little bit of extra hydrogen, react a little extra oxygen, and shoot for 39.2 grams of water and lose 8%. All right, that's all for percent yield. Hope the video has been helpful. Feel free to leave any questions or comments in the comments section below, and thanks for watching.